Hello everyone, welcome to today's class. This is Teacher Simon taking you through Cambridge International AS and A-Level Mathematics for May, June 2023, paper 4-2 for questions 1 to 4. Question 1, a particle of mass 1.6 kilograms is dropped from a height of 9 meters above the horizontal ground. The speed of the particle at the instant before hitting the ground is 12 meters per second. Find the work done against resistance. Now I can use two methods here. The work energy, I can use the energy method. I can also use the method of forces and the equations of motion. So suppose I have my particle here. Okay, it is falling through this distance here, which is 9 meters. Okay, the distance here is 9 meters, so you can write it like that, 9 meters. Now, then this particle here has gotten its weight, which acts downwards. Okay, 1.6 grams. Like that's it is mg, and then automatically there has to be the normal reaction there. You see that? Then at this point here, there is potential energy because there is vertical height. Okay. And then when it reaches down here, it will have kinetic energy because there is speed, which is 12 meters per second. Then, using the work energy method, we have work done by the driving force minus work done against resistance is equal to the change in mechanical energy. And since this one is just a free fall, then there is no applied force. The applied force has to be on that particle. You apply that force and the particle moves until it reaches down here. So it is not there. Therefore, the work done by the driving force is 0. And then work done against resistance. So we are going to have, it is the one actually we are looking for, work done against resistance. So work done against resistance. Then change in mechanical energy. Mechanical energy is always equal to potential energy, then plus the kinetic energy. And potential energy is mgh, kinetic energy is a half mv squared. Okay. Now, so we look at the final. So final, we come to this part here on the ground, which is actually due to kinetic energy. So I will have a half, then m is 1.6 times the speed is 12 squared. And then minus here, I'm having potential energy. So potential energy is mgh, so 1.6 times 10 times 9, okay? Now, work done against resistance here is going to be 12 squared is 144. So divide by 2, 72. Now, when I multiply that by 1.6, what do I get? In other words, let us just simplify. What is this side? So putting everything in the calculator, we get 0.5 into 1.6, then times 144. 12 squared is 144. Then minus, we have 1.6 times 10 times 9. So altogether, it gives us negative 28.8. Negative 28.8. That means when we divide all through by negative 1, work done against resistance is given by 28.8 joules. Okay, because energy is measured in joules. Now, alternatively, this is the alternative approach. Alternatively, I'm going to have v squared. Okay, v squared is equal to u squared plus 2as. So the final speed is 12. So 12 squared. Initial is 0 because the particle is just released, right? The particle is just dropped from the height above, so that will be 0, and then 2, we shall have 2 here. Since it is dropping down, we would have used acceleration, which is equal to negative 10 because it is going down. However, there is resistance to motion. Okay, there is resistance to motion, so that means the acceleration is no longer 10. So we need to find that acceleration of the particle. Okay, so acceleration of the particle, but then the distance traveled is 9 meters, so times 9. So meaning acceleration here will be equal to 144 here, then divide by the 18. Okay, because when you get 2 times 9, you get 18. 144 divided by 18. 144 divided by 18. And we get 8. So our acceleration is equal to 8 meters per second squared. Then after getting this one here, we are supposed to now find the resistance. So using F is equal to MA, okay? Now, what is the resultant of these forces? This one is going down, okay? Then minus the R, the resistance to that motion. Actually, it is not the normal reaction because it is not on a plane, okay? At first, I had said that this is the normal reaction. It is not on a plane. It is just held up and then dropped, okay? Now, we are going to have this 1.6 G minus the R, that is the net force that takes this particle down. 1.6 G minus the R, then is equal to the mass of this particle, which is 1.6. That is 1.6 times our A, which is 8. So making R the subject, we shall have 1.6 times 10, that is 16. Then minus 1.6 times 8, that will give us our R. So what is R? 16 minus 1.6 times 8. Then this one is giving us 3.2 newtons. So this will be 3.2 newtons, okay? Now, we are told to find the work done against resistance. And you know that work done is the force times distance. So we shall get the resistance here times the distance, which is 9. So 3.2 times the 9, what do we get? 3.2 times 9. This gives us 28.8, you see? So either way, you get the answer, 28.8 joules. That is our answer. Question 2. Particles A and B of masses 3.2 kilograms and 2.4 kilograms respectively lie on a smooth horizontal table. A moves towards B with a speed of v meters per second and collides with B, which is moving towards A with a speed of 6 meters per second. In the collision, the two particles come to rest. Find V. Okay. Now, we are going to use the principle of conservation of momentum. I have these particles here. This is particle A. I have particle B here before collision. So this is 2.4 kilograms. This is 3.2 kilograms. You see? So U of A is going forward and its initial speed is V. Okay? Then U of B is going towards A and its initial speed is 6. So that means the velocity is going to be negative 6. Okay? Because for momentum, we use mass times velocity, not speed. So that means the direction is very important in this case. Then after collision, we are having A here. We are also having B here. Okay? Then, of course, this is 3.2 kilograms. Then this is 2.4 kilograms. They are all brought to rest. So that means velocity of A is 0. And then the final velocity of B is also 0. Now, the principle of conservation of momentum states that momentum before collision and momentum is product of mass and velocity. So MA, UA, then plus MB, UB. The momentum before collision is equal to momentum after collision. So this is MA, VA plus MB, VB. Now, MA, the mass of A is 3.2. Its velocity is V. And then the mass of B is 2.4. Its velocity is negative 6 because it is moving in the opposite direction. Then this way, of course, we have 0 and then 0. So meaning V is going to be, this is a negative. So when it crosses, it becomes a positive, right? Then we are going to have 2.4 times the 6, then divide by the 3.2. So what is our V? We put in the calculator. 2.4 times 6, then we divide by 3.2. And we get 4.5. So we shall write here 4.5 meters per second. That is the speed with which A moves which A moves to go and collide with B. Then part B, find the loss of kinetic energy of the system due to collision. Now, the moment they say loss of kinetic energy, that means the final kinetic energy is less than the initial kinetic energy. Okay, so we need to find the total initial kinetic energy. kinetic energy. So you have to look at the kinetic energy due to the movement of A, and kinetic energy is a half mv squared. So a half, the mass of A is 3.2, its velocity is 4.5. We have found it, so we square this, and then we add the kinetic energy due to the movement of B is a half, then times m is 2.4, and then its velocity is -6. So you put -6 here and then you square. So here, what do we get? 0.5 times 3.2 times 4.5 squared. Okay. I will even add the other one, 0.5 into 2.4, then times 36. And that will give us altogether 75.6 joules. Okay. Then after that, we are supposed to find the total final. Okay. Total final kinetic energy. Okay. Total final kinetic energy. Of course, since they were brought to rest, we just have that as 0. And that means the total loss in kinetic energy shall be equal to the 75.6 subtract 0. And all the kinetic energy they had, in other words, disappears on collision because they come to rest. So that is 75.6. Question 3, coplanar forces. Coplanar means in the same plane. So coplanar forces of magnitudes 30 newtons, 15 newtons, 33 newtons, and p newtons act at a point in the directions shown in the diagram, where tan of alpha is 4/3. Now I'll begin from here, because when I resolve these forces, I'll need cos of alpha and sine of alpha. Okay. Now, using this right angled triangle and applying SOHCAHTOA, tan is opposite, which is 4/adjacent, which is 3. That means I will need the hypotenuse here. So using the Pythagoras theorem, the hypotenuse is going to be the square root of the adjacent squared, then added to the opposite squared. So 9 plus 16, that is 25, root of 25, that one gives us 5. So this simply implies that cosine of alpha is going to be equal to adjacent out of hypotenuse. And also sine of alpha is going to be the opposite over hypotenuse. Okay. Now, we can resolve these forces. So to resolve these forces, I've always drawn them on one diagram like this to be so smart and organized. Okay. To be so smart and organized, you put them all here. So we are going to resolve these forces. When you resolve them, I've always said that closing is cosine. There is a vertical line here, it goes through here. So you resolve this horizontally and you also resolve it vertically here. The same thing with this, put it down here, put it up here. This one, put it here, you also put it here. The P, put it here and you also put it here. So all of those, we are going to resolve them vertically and horizontally. Now, when we close, it is cosine. So close the 15. What do you get? You will get 15 cos alpha. So here I have 15 cosine of alpha. Okay. Then close this one here. That will be 33 cos of alpha. I will have here 33 cosine of alpha. Now, when you open this 15 up here, it will give us 15 sine of alpha. So we put here 15 sine of alpha. And then resolving this p here, in fact, before I go to this, resolve this one here vertically. So that will be sine 33. I'll have 33 sine of alpha. Then come to p. Put it here. That will be p cos alpha. P cos, actually theta, not alpha. And then also bring the 30 here. That is 30 cos alpha. I don't know why I'm saying alpha. So it is 30 cos alpha, cos theta again. Cos theta. Okay. Now put the 30 up here. So we shall get 30 sine of theta, and then put the p down here. We shall get p sine theta. So that is our diagram there. Okay. Now they are saying that the system is in equilibrium. If the system is in equilibrium, that means the resultant in x is 0 and the resultant in y is also 0. So let us have horizontally, when we resolve them, what is this way is equal to what is this way. Okay. So we shall have 30 cos theta, then plus p cos theta. This one is equal to 15 cos alpha plus 33 cos alpha. And then we shall have p. This will be, if I factorize out the cosine, because cosine is common, then here I will have 30 plus p. Okay. Then this side I will have 15 plus 33. That one will give us 15 plus 33, that is 48. Yes, we shall have 48 cosine of alpha. So what will cosine of theta therefore be? It is 48 times cosine of alpha. We got it as 3 over 5. So 3 over 5. Then we shall divide by 30 plus the p. So we can simplify this and we have 48 times 3 over 5 on the calculator. 48 into 3 out of 5, which is 0.6. So this one gives us 144 over 5. The decimal, that is 28.8. So I can write it as 28.8. Okay. Then out of 30 plus p. Then we can go now horizontally. This is our equation 1. Sorry, we can go now vertical. What is here is equivalent to what is down here. I think down here we must be having cosine of alpha. Okay. So we shall therefore have 30 sine of theta plus 15 sine of alpha. Then we get p sine of theta, and then plus 33 sine of alpha. Remember, sine of alpha is 4 over 5. Now we shall collect like terms together and we put sine onto one side. So when I put it here, it will be a minus. Okay. And I factorize it. So I will have 30 minus the p. Okay. Then sine of theta. And then I'll take this one to this other side. We shall subtract. Okay. So 33 minus 15. That one will give us 18. Okay. No. Yes, it will give us 18. So 18, then sine of alpha. So meaning sine of theta is going to be equal to 18. Sine of alpha, remember we have it as 4 over 5. So we shall put here 4 over 5, and then we divide by the 30 minus p. So what is therefore our sine of theta? Simplified. So sine of theta is going to be equal to, what do we get here? Then divide by 30 minus p. This will be our equation 2. So when we put in the calculator, what do we get? 18 into 4 out of 5. This one gives us 72 over 5, which is 14.4. So here we have 14.4. So that is equation 2. Now, we can solve these ones. If we get equation 1, we square plus equation 2, and we also square it. You know that sine of an angle, okay, squared plus cosine of an angle squared will always be equal to 1. This is the Pythagorean identity in trigonometry. So that means I'll get my sine, which is 14.4 out of 30 minus p, brackets, I square it, it is my sine, okay, then plus the square of the cosine, which is 28.8. I will divide by 30 plus p squared. then this one will be equivalent to 1. And that is exactly what they have told us to show. So that is our answer there. Proved. Part B, verify that P is equal to 6 satisfies this equation and find the value of theta. So for P, which is equal to 6, remember we have 14.4 over 30 minus P. So we shall have 14.4 over 30 minus P. Let me first write this equation again here. Then plus, we have 28.8 divided by 30 plus P. I can say P plus 30. And then this one is also squared, which is equal to 1. So for P is equal to 6, I will substitute here 14.4 out of 30 minus 6, I square. You just need to substitute here. And then you see, does it give us the 1? So 6 plus 30. Does it give us 1? Let's check and see. So I will put 14.4 out of 30 minus 6, then squared, then plus, I can put 28.8 divided by the 30 plus 6, which is 36, right? Then squared. It actually gives us 1. So therefore, it satisfies. Okay. Then they said, and find the value of theta. Find the value of theta. Now, we need to go back to our equations here, and we substitute in any of them, okay? Maybe this one here, or this one of sine, okay? So I'll take the first one. Cosine of theta is equal to 28.8 out of 30 plus P. Okay, so using cosine of theta, which is equivalent to 28.8, then I divide by the P plus 30, okay? That means my theta is going to be equal to the arc cos of 28.8, then divide by the 6 plus 30, okay? So putting everything in the calculator, what do we get as the value of theta? The arc cos of 28.8 divided by 36. And this one gives us 36.9 to 1 decimal place. 36.9 to 1 decimal place. As simple as that. Question 4. An athlete of mass 84 kilograms is running along a straight road. Part A. Initially, the road is horizontal and he runs at a constant speed of 3 meters per second. So for constant speed, you should always know that acceleration is equal to 0. The athlete produces a constant power of 60 watts. Find the resistive force which acts on the athlete. So if this is my athlete as a particle, we have the driving force. Then here we have the resistance. Okay. Now, using force is equal to ma. Since it is constant speed, that means the driving force will always be equal to the resistance force. Now, and if I put this driving force, first of all, power is equal to the driving force, then times the speed. So meaning the driving force shall be equal to the power, which is 60, divided by the speed, 3. And this one will give us 20 meters, newtons, okay? Then using this one here, the driving force minus the resistance force, then it will be equal to 0 because acceleration is what? 0. So the resistance force will be equivalent to the driving force, which is 20 newtons. Then part B, the athlete then runs up 150 meter section of a road which is inclined at 0.8 degrees to the horizontal. The speed of the athlete at the start of the road is 3 meters per second, and he now produces a constant driving force of 24 newtons. The total resistive force which acts on the athlete along this section of the road has the constant magnitude of 13 newtons. Okay, now they are specific here. They said use an energy method to find the speed of the athlete at the end of the 150 meter section of the road. I'm going to draw something here, as you have always followed that we do the drawing to help us identify the forces acting on the particle and everything that we need to use. So there is generation of vertical height here, okay, and that is h. Now at the start here, u is equal to 3. That means there is kinetic energy here, okay, due to the speed. And then here we are supposed to find this speed. So this speed we don't know. So therefore there is kinetic energy because it is dependent on the speed. And there is also potential energy since we have the vertical height. Now this section here is 150 meters. Okay, 150 meters. There is a constant driving force here which is taking this particle up here, which is 24 newtons. Okay, this is this one here is a right angled triangle. So I can use my SOHCAHTOA sine of that theta, which is 0.8 degrees. Sine of 0.8 degrees is equivalent to the opposite, which is h over the hypotenuse 150. So meaning h is going to be equal to 150 sine of 0.8 degrees. Okay, so this is 150 sine of 0.8 degrees. Now we are going to use the work energy method, which states that work done by the driving force, okay, minus work done against resistance, work done against resistance, okay, is equal to change in mechanical energy. See that? But what is mechanical energy? We said mechanical energy is equal to the potential energy plus the kinetic energy. Potential energy is mg times the vertical height. Kinetic energy is a half mv squared. You see that? Now, work done by the driving force. We have the driving force here, which is 24, traveling this distance of 150. So we shall have 24 times 150, and then minus work done against resistance. So there is a resistance force that I actually never put here. They said is 13. Total resistive force is 13. So this one 13, but it has traveled the whole of this distance up there. Okay, so we are going to have 13 then times 150. Okay, then from there this one is equal to change in mechanical energy. You get the final minus the initial. So the final is here. We have kinetic, and then we also have potential. So the potential energy is mgh. So the m, what is the m here? The mass is 84. Okay, now 84 times the g, which is 10, then times the height, which is 150 sine of 0.8. Okay, then after that we are going to add on the kinetic energy, which is a half mv squared. We don't know that v is the one we are looking for. Then minus the initial kinetic energy. Okay, the initial kinetic energy here. So we shall have a half, then times the mass, which is 84, times 3 squared. Now on the left, when we put everything in the calculator, what do we get? 24 times 150, then minus 13 times 150. Altogether it gives us 1650. So I write 1650. Then on the right, I'll have 840 times 150, 840 times 150. That will give me 126,000. So I'll have 126,000 sine of the 0.8 degrees. So this one I've left it because I want to do everything all at once, and then I round off at last. Then plus, of course, a half of 84, that will be 42 v squared. Then I will subtract 42 times 9. That one gives us 378. 378. So what will be our v? So take this one this side and also this one this side. Then after we shall divide by 42, then we take the square root. Okay? So V shall be equal to the square root of 1650. When this one crosses, it is a plus. Okay? So plus 378. Then minus 126000 sine of 0.8. Then we shall divide by the 42. So putting everything in the calculator, what do we get? Square root of 1650 plus 378 minus 126000 sine of 0.8. You have to check the mode of your calculator before you use any trigonometric expression. So mine is in degrees already. Then 42. And this will give us 2.53 to 3 significant figures. Velocity is equal to 2.53 meters per second to 3 significant figures. So this has been it for this first part of the paper. Thank you so much for watching. May God bless you. If you find the content very helpful to you, kindly like, share, and even subscribe. See you in the next videos.